Here's Miss Elkins again. We're talking about, or just a reminder, on dependent and independent variables. This should be a quick note. It's just one page on the front only. So let's talk about what is a dependent variable. The dependent variable is the output of a function. Okay. Its value, the value depends on the value of the independent variable. Okay, so the output of a function, the value depends on the value of the independent variable. It is the vertical axis on a graph and comes first in a table. Okay, that's how you know it's the dependent variable. It'll be on the vertical axis or the y-axis, and it will come, sorry, I messed up. It will come second in the table. It won't be first. It'll always be second in a table. Okay, sorry about that mistake. Okay, the independent variable is the input of a function or a relationship, and it determines the value of the output. Okay, so it's the input of a function. The independent value or variable determines the value of the output. It will always be the independent variable will always be the horizontal axis on a graph and comes first in a table. I don't think I have room to write all that. In a table. Wow, I should have written smaller. Okay, so that's how you know the difference between the dependent and the independent variables. First of all, if it's a graph, it will be the vertical axis for the dependent variable, and it'll be the horizontal axis for the independent variable. If it's a table, it will come first if it's independent and second if it's dependent. So that's kind of a trick or an easy way to remember that. Let's look at these examples and let's describe the independent and the dependent variables. Example 1, Danny opened a savings account with $50 and deposited $10 each week for 4 weeks. Now here's the table. On the top it has number of weeks. On the bottom it has money saved. All we need to know right now is what is the independent variable. And as I told you, the independent variable comes first. So that tells me that the number of weeks on the top of the table, number of weeks, That part is the independent variable. And then the total money saved on the bottom, that's the dependent variable. Okay, so most of the time is an independent variable, but it always is going to be on the top. And so you can see the number of weeks. If no weeks pass by, that means he's not saving any money. Okay, let's look at example 2. Student government is selling carnations for Valentine's Day for $2 each. On the top, it says number of carnations, 10, 20, 30, 40, 50. On the bottom, it says amount received, 20, 40, 60, 80, 100. The independent variable is always on the top, so that tells me that the number of carnations is the independent variable. The dependent variable is always on the bottom, so that tells me that the total amount received is the dependent variable. It's really that easy. What's on top is the independent, what's on bottom is the dependent. If the table is vertical, the independent variable comes first and the dependent comes second. All right, example 3, a little bit harder. Derek's earnings from lawn mowing is shown in the graph below. And as you can see on the graph below, on the horizontal axis, we have number of lawns mowed, 2, 4, 6, 8, 10, 12. And then on the vertical axis, we have earnings in dollars. And it goes from 50 to 100 to 250. I'm sorry, 50 to 100, 150 to 200 to 250. So, as I told you earlier, the horizontal axis, the x-axis, is always the independent variable. So the independent thing here is the number of lawns mowed. And you can tell yourself, if I don't mow any lawns, I won't make any money. So that tells you the money that you make is dependent on the number of lawns you mowed. And of course, the dependent value is the total earnings. Now here's another little extension question. How much is earned per lawn? If I look at the chart, if I look at the graph, I can see that if who's mowing lawns? Derek mows 2 lawns, that he makes $50 because that's where those 2 lines intersect. We want to know how much it is for 1 lawn. Well, I can pretty much guess that on the table, this would be 1 because it goes 1, 2, and this would probably be 3, and 5, and 7, and 9, and 11, and 13. So those in between numbers are there. And then I just have to figure out, well, what would be halfway between 0 and 50? $25. He's making $25 per lawn. Another way to do that, to find out the unit cost or the unit rate or whatever it is that you're trying to find out how much it is for one, another way to do that is to take your y value and divide it by your x value. In this case, there's a y value of 50, and we divide it by the x value of 2, and that gives us 25. And that'll work with any one of these because this y value is 100, and this x value is 4. 100 divided by 4 is also 25. This value is 150. This value is 6. 150 divided by 6 is also 25. It'll work all the way up to the very top, where if you have 250 divided by 10, it's still going to give you 25. So that's a key way to find the unit rate or the amount per one, is divide y by x. And then the last example, Felicia's babysitting earnings are shown in the graph below. As we see, their earnings are here on the vertical axis. The hours are here on the horizontal axis, which tells me that the number of hours that she babysits determines how much money she makes. If she babysits no hours, she will make no money. And then her total earnings are the dependent variable. Okay, and again, we want to know how much is earned per hour. This one's a little bit trickier than the other one. For 3 hours, it looks like she earns $21. If I divide the y value by the x value, or 21 by 3, it tells me that you are earning $7 an hour for babysitting. Okay, I hope that you got something out of these notes today. I hope that you're doing well there at home, and I miss you, and I hope I'll see you soon. Have a great day. Talk to you soon.